All right. Well, good afternoon, everyone. Thank you for attending today's webinar on unusual spaces and the energy code. This webinar will be recorded, and the recording is available for all attendees within the next week or so on the Code Adoption Toolkit website. If there are any issues with audio, please write me in the chat. And my name is Erica DeLello, and I'm a project manager for Noresco. This series is sponsored by the Colorado Energy Office with training materials created by Shums Coda. So Hope and I have been working with the Colorado Energy Office for a couple of years now to provide trainings just like this one. Here we have a list of the trainings that are upcoming. We're towards the end of our series now, but I know Excel also has a series being worked through as well. So Hope, I don't know if there's a link or anything that you want to share, but feel free to do that.
Okay.
Then we also offer technical assistance for jurisdictions or tailored group trainings for jurisdictions, just industry professionals in general. So feel free to reach out to me if you have any questions about that. We're here as a resource for the state of Colorado. So use us. That's why we're here. And then many of you know probably about this Code Adoption Toolkit if you've joined these webinars in the past, but all of the resources that are available on there, there's cost information that I'm actually working on updating for 2021 currently too, but then there's a summary of changes, all different kinds of resources that are here to assist you guys. The latest addition in resources is the helpline, and the helpline has been created in conjunction with Xcel Energy to be available to anyone in Colorado to submit a question about any of the I codes. So then within a matter of about 2 business days, subject matter experts like Hope respond to you all, and hopefully we answer your questions accurately and to your satisfaction. But this applies to any industry professionals. So bookmark the link. I'll put it in the chat in a little bit as well, so that you have it. So just a couple of housekeeping items throughout the webinar. We of course want to encourage questions, so please use that Q&A function, and I'll let Hope know at the end. There's also the ability to raise your hand and ask a question, so I can then unmute you, and Hope, you can have a conversation with Hope and I. Lastly, there will be a survey window that pops up following this webinar. Please take a minute to provide feedback so we can continue to improve on these webinars. So today's presenter is Hope Medina, and Hope is an energy and sustainability consultant for Shums Coda Associates. She's worked on a national level to develop, promote, and assist with adopting energy and green codes. And she is a governing member of the ICC Sustainability Membership Council, a consensus committee member, and a task group chair of the National Green Building Standard for several code cycles now. So we are in good hands. That said, Hope, I will stop sharing my screen and let you start your presentation.
All right, well, let me share my screen. All right, here we go. So I'm so glad that we're able to have this conversation, and thank you, Erica. So today we are going to talk about some of the more unusual spaces that are starting to come into somewhat of the mainstream now, and how the energy code applies to it, whether there are special items that need to be looked at or special items that don't need to be looked at. And so today we're going to kind of talk about how and where and what we need to look at for these unusual spaces. So we're going to have a little bit of a combination. There'll be some aspects that are going to be residential provisions, some aspects that are going to be commercial provisions, but they're all here in this one webinar just for you. So let's get started and let's talk about log homes. So log homes is one of those unique things that came into in the last couple editions, where if you go to R402.1 and you go to where the exceptions are, it states that the building thermal envelope does not have to comply with what you find in R402 of the IECC if it is designed to and in accordance with ICC 400. Now, with that being said, ICC 400 is the standard that is developed by ICC's process for log homes, and it does include some provisions in there for the thermal resistance of that thermal envelope and also dealing with some air sealing. So if it happens to be designed to that, whether you're on the 18 or the 21 IECC, it actually will be, they'll need to be designing to ICC 400, the 2017 version. Now the 2022 version just came out, but neither of those are referenced in the 18 or the 21. So, and also the other thing I want you to be aware of is this option for log homes and the exemption on the thermal envelope is only an option for residential projects. So let's dive into what the heck this standard is all about. So ICC 400 is a standard that talks about the design and the construction for log structures. And as you can see here, it does incorporate a little bit on the residential side and a little bit on the commercial side. But the only provision, like I said, or the only exemption is on the residential aspect of it. So that's what we will be focusing on today. So saying that, what we are going to be looking at this very moment is how do we deal with that thermal envelope, right? Because the intent of having that log home is so that you have that outside outdoor log cabin feeling where you can see the wood right there as you're sitting on the couch. And that's the intent, not necessarily do they want to see where it's been furred out so that we can get that insulation in the wall and you have that drywall. So the intent is you want to have that aesthetic pleasing feeling of the log homes. And so with that, how you deal with the quote unquote like R value is you're going to have three options. You are going to comply with one of these three options. One is your prescriptive method, one is your test method, and one is the calculation method. So let's take a look at that a little bit further. So when we talk about the prescriptive method, you're going to utilize one of these two options within that method. You have the U factor method, and then you also have the thermal envelope method. So you're either going to comply with the section 305.3.1.1, or you're going to comply with 305.3.1.2. And so 305.3.11, which is the U factor, is talking about how the assembly, and you're going to take a look at what you find in table 305. And so this table is a table that's a little bit more complex than maybe what we're used to, because there's a lot that's involved with it. So you're going to take a log. You're going to need to know what that average width of that log is going to be. And that's something that should be provided on the plans. And from that log, you're going to see what the U factor is shown on here. You'll see that it's a 0.0 number. And of course, the lower the number, the better it is. But where things kind of fit in is you see, let's take 10 inches. So we see that column for 10 inches. On the very right-hand side, you have the specific gravity, and that's talking about, I believe it's the moisture content that you're going to find in that log. And all this is provided for you as code officials. That information is provided for you. So if they are utilizing a specific gravity and it happens to be a 0.29 and they are at 10 inches, then they are deemed that it is a 0.060, and that's how this table is going to work. Now, the thermal envelope component of it is probably a little bit more familiar than, what you have seen in the past. This one looks very familiar to what we've seen within the IECC, right? Table R 402.1.2 or 3, depending on which edition you're in. We have our climate zones. We know what climate zone we're in. Now we're going to take a look and see for our log wall. It tells us what our diameter again is, right? So if you are in climate zone 5, your minimum diameter of log has to be 5 inches, and then it has to have the SG, which was that like what we saw here, the specific gravity on that left-hand side, that has to be equal to or less than the 0.50. Or what you're going to do is have at least a 7-inch log, and then you can have your SG that's greater than 0.50. And then, of course, you're still going to have to do your fenestration. So you're going to follow that table. Do you have fenestration? Do you have skylights? The solar heat gain coefficient, is that part of it? All of that has to come in. And then you have your ceiling R value. Now your ceiling R value is going to have a requirement of an R49. Now, that is to say, I know quite often, there's that, I still want to have that aesthetic pleasing feeling of the ceiling or roof. And what I will say is, these tables address walls as far as log building. They address walls and being able to use the different various sizes of log walls, but they don't really address it as far as what size of log can we utilize for our ceiling to have this particular value. And so with that, it still states that you are going to need to have an R49 in climate zone 5 as your ceiling value. Now, doesn't mean you can't do it above deck and have it above deck, so you still have the aesthetic look of the wood, log for that, but you will have to have something in place for that. And then, of course, if you do fur out your walls and you are going to use wood frame walls, now you're going to do the R20 or 13+5, which we're very, familiar with, and it's pretty similar to how you would look at it. So are your floor values, so are your basement wall values and your crawl wall values, and then your slab R value. And one of the columns that, if you notice on here, is that heated slab R value. Now that is different than the typical table that, that we're used to. And so it does have the value of a heated slab. And it states that you're going to have that R, and in this case, 10 continuous, completely under slab if you're going to have a heated slab. So the second option that you have is going with that test method. If you don't want to mess with those tables and trying to figure out what your specific gravity is for your logs, then you have the option that you can do this test method. And what it is it's a physical testing of what that thermal resistance is going to be. And then there are some standards that are involved. So the ASTM C11719 is for your standard test method for heat flux and measurements of thermal resistance properties by means of the guarded hot plate apparatus. And then you have other 2 tests that are going to deal with various other components of it. And then you have this very lovely sorry about that. Okay, we're not touching it here. And so now we have the calculated method, and the calculated method is where you're going to start taking the coefficient of the transmission of the log walls and using these particular equations. And so there's a very in-depth calculation that will need to be performed, and dealing with, again, you're dealing with, inside film, outside film, size of log, the percentage of the wall that's going to be considered, that's going to utilize log. And all of this goes into this particular calculation. Again, as a plans examiner, inspector, or builder, this wouldn't be required of you. It should be presented to show that you meet these requirements for it. And so here we go. And then here's the remainder of that particular calculation that will be utilized. Now that we've kind of discussed a little bit of what you see as far as how to determine the quote unquote insulation values that, typically we would just see that lovely little R value on that pink insulation that makes it very easy for us to do. We still have to take into account there are other components within that thermal envelope, and one being air infiltration. And I think when everything is said and done, I really feel that ICC 400 does a fairly good job in being able to address what those concerns are or what those issues are. And if you recall, if you go into table R402.4.1.1 of the IECC, then that's your air barrier criteria and insulation installation table. You'll see that there's a footnote that says that log homes, when designed to ICC 400, are exempt from the air leakage requirements that you would find and required out of that particular table. And that's because they have this nice little section that deals with it. So it states in here that you are going to comply with sections 306.1.1.1 through 306.1.1.4. So let's go ahead and take a look at what some of that is. So part of this talks about, right, you need to figure out how you're going to deal with your joints. And so what is going to be required is you're going to have some sort of sealant, and that sealant has to be compatible and maintain, the weather seal of what's going on in there. And then it also has to have that limited air movement capability with it. And so you also have to take into account that, you're going to have penetrations that are coming through this. And it states here that those penetrations are going to need to be sealed, and that seal has to be able to withstand, weather and the air infiltration for that. Now, here's where, the question then again comes into play when you start talking about that sealing. And so what they state is that you're going to have some sort of pattern sheathing or decking seams that you're going to have to address for this. And that's just because, again, you don't want to leave it open where you have that gap, because we don't want the air to be coming through a very exposed area. So you're going to have to utilize some sort of method that is going to restrict that airflow. And it's also not only going to restrict that airflow, but not allow the moisture to really enter into that structure too. And then anytime you have logs, because you want that aesthetic look, often you'll see logs that go from one end of the house all the way through the other. So if you have any type of structural roof or membrane or flooring that penetrates through the log walls, right? If you have that, where you have that going through like that image there, you see the ceiling, the logs are going all the way through that log wall. You are going to have to make sure that those penetrations, again, are able to maintain the fact that there can't be any moisture that comes in, no weather that comes in. And it also has to have a very good air sealing component to it. Rough openings and wall, are designed and to make sure that, again, there's no air or water infiltrations that's going to come into these openings. So this is what they talk about for your walls and your doors. Very similar to what you find, really within the IECC, just addressing the fact that this construction is a little bit more unique than what you're going to find with the typical, wood frame construction. And then, of course, I think something to keep in mind, which, is the fact that you have to have some sort of protection, for the wood structure itself. And the part of it is so to help to ensure that, we don't want, more moisture getting in than what was already designed for. And we don't want any moisture to get out, because what happens then, the logs swell. and then they shrink. And by swelling and shrinking, all those seams and joints that have been sealed to limit any type of moisture or any type of air coming in and out of it are no longer going to be, in good standing for that. And so the whole point of this particular portion of it is just making sure that, we're maintaining that the log is going to have very little, expansion or shrinkage to it. Okay. So that was all the fun and excitement that we had about log homes. I hope it wasn't, that scary, because when everything is said and done, it's just the thermal envelope that is slightly adjusted and a little bit different than what you're going to see out of the IECC, but your mechanical is still going to all comply. Your lighting is still all going to comply. Your service water heating requirements are all going to comply. The only thing that's slightly different is your thermal envelope. So shipping containers. I don't know about any of you out there, but I have had the fun and excitement of doing a plan review for shipping containers, and it's been on the residential side, and it's a very unique concept that's really starting to kind of take off, because it's deemed as it's looked at as being more of a sustainable practice, resilient practice, green practice, however you want to look at it. But it's coming into play. And so with that, there are a lot of questions on what you need to do, because there isn't a very specific section within the IECC, whether you're talking residential or commercial, on how you're going to deal with that. So when we talk about shipping containers and we talk about the residential requirements, the things that you think about is, okay, so I need to know how that thermal envelope is going to work with it. The systems, whether that's the service water heating and the mechanical, however it's going to be heated and cooled. We're going to be looking at some of that. The electrical power and lighting systems, that's going to be something that's, going to be looked at. And then of course you have, if you happen to be under the 2021, your additional efficiency package options. And those are going to be very unique in how they're going to be applied to when it comes to shipping containers. It's just something that when a shipping container project comes in, that there'll have to be a lot of forethought on how that's going to be addressed. So these are the things that, it's similar pretty much, actually, if you were doing, the traditional stick framed house, these are all the items that you're going to be, concerned with for that. It's the same for a shipping container home. And when we talk about commercial, it's the same thing here too, right? You're still going to be looking at, whether or not that building thermal envelope meets everything, with the insulation, air leakage, all the fun stuff. Do the things come in? The mechanical systems are still going to have to comply with it. The service water heating, electrical power, lighting systems, the additional efficiency package, and maintenance and commissioning, if it, is required to have the commissioning for it. And the image that you see there is actually I'm trying to think of how it's called. I think it's called the Shipping Container Mall. It's an outdoor mall, completely comprised of shipping containers. What you see there was the elevator that was utilized for that. So, you can use these, and they're getting used. So let me see. There we go. So what are the things that we need to talk about when it comes to shipping containers? And I think probably the biggest question is, what are you doing, whether you're designing them, reviewing them, building them, or inspecting them when it comes to the thermal envelope, right? Because there's a lot of questions. There isn't, like I said, there isn't a table right there that says, hey, use me for shipping containers. There's nothing labeled, shipping container table, thermal envelope, woohoo, the components. So what is it that you're going to use? What do you need when it comes to your insulation requirements? And so I've had several discussions actually with ICC, and the approach that is really being recommended. And so residentially, they're saying that if they're going to utilize the shipping container and it's going to be a component of an assembly, that really how you should be looking at it is using either table 402.1.4 if you're in the 18, and 402.1.2 if you're under the 2021, which is your U factor table, that assembly approach, right? You're going to take the metal sheathing, right? That metal exterior of the shipping container, and then whatever type of assembly that you're going to utilize, and add everything together to see, what it is and how it's going to meet these particular values. I know that often, as you saw in this previous picture, they are wanting to utilize as much of that exterior look to it. Maybe it'll be painted or so forth, but they want it to make it known that what they're using is a shipping container. And you can do that. But, of course, when we start talking about that interior, it doesn't exempt you from using that thermal envelope. So this is the approach that you're going to want to use. Keep in mind too, that, these shipping containers are fairly, airtight and moisture tight, right? Because the intent is they don't want anything of that getting into whatever's being housed in those shipping containers prior to its second life as a structural building. So that they are pretty tight. So you have to keep in mind too, if you're designing or you're doing a plan review to it, are you, trapping moisture in a wall, right? So we want to make sure that the walls have the capability, if there is some sort of moisture that gets in, that it is able to escape for it. So that's where, really thinking about how that assembly approach is going to work. Now, for the commercial requirements for a shipping container, again, it's recommended that you utilize the U factor, C factor, F factor method for it. But at least in this particular table, you do have some options. So, are they going to put that insulation entirely above deck? And if that's the case, then you need to use this particular row for it. If they are going to create where they have an attic, then, then they're going to use the attic. Or they're utilizing it as that they're considering it a metal building. And so they're utilizing the metal building row for that. So with that being said, I think on the commercial side, it gives you a lot more options on how you want to really look at this and be able to design and, review for it. Now, the other thing that you have to think about is air barriers, right? Air barriers, it's not just black and white as far as how do you deal with this type of material and structure, and make sure that you're going to comply with how the air barrier and air sealing is set up. So let's talk about what you're going to do on the residential side of things. So residentially, you are just going to follow table R402.4.1.1, right? And that's the lovely table that gives you what the component is, and then tells you in the next column your air barrier criteria. So you have, let's say, your ceiling. Well, your ceiling is now going to have to make sure that the air barrier in any drop ceiling or soffit shall be aligned with the insulation, and any gaps in the air barrier shall be sealed, and the access openings, any drop down stairs or knee wall openings to conditioned attic space shall be sealed. So if you have that condition in that shipping container, that's what you're going to do. But basically, you're still following this table, and it's going to get you to being able to do a blower door test, right? Because that's the intent of this, right? It's a roadmap to lead you to success. And it doesn't change if you happen to have a shipping container. There's no exemption saying, hey, you are exempt from the blower door test if you utilize a shipping container for your home. So with that being said, you're still going to want to really follow the components and the information that you find. And in some of the areas, you probably are going to want to follow it very, very closely, right? So you have that shipping container and you've got your nice tub that you like to relax in, have some music on, candlelit, and just, decompress from the day. You don't want the cold air and the coldness from that, the metal that's your exterior now, basically sucking all the warmth out of that tub, right? So you're going to make sure that you've got that air barrier, you've got that insulation there so that you can still enjoy the warmth of the tub. And so, there's probably a little more things that you might, really focus on a little bit more dealing with, that steel metal structure. Now, when we talk about the commercial side of things, this is where it kind of gets, a little bit more complex than on the residential side. And so if you are in the 2018, you're going to follow C402.5, which, is the typical, air leakage section. Now, for the 2021, again, you're going to utilize C402.5, but remember that air leakage testing may be required for these. So you have to keep that in mind and you have to really kind of think it through. And so for the 2018, you still have the option and you are still required to either utilize the material option, which in the IECC, you have those 16 already deemed to comply materials that can be utilized. It does have sheet, and let's see, I'm trying to think, sheets of steel that's on there. I'm not sure that this would necessarily comply with that, but it's something to maybe keep in mind of your, or the assembly approach, not necessarily seeing that there's going to be an assembly approach used for the shipping containers, or you can do the testing. Now in the 2021, again, you can do the material, or you can do the assembly, or you can do testing, but for certain occupancies, it is required that you have to do the testing for it. So whether you use material or assembly, you are going to be doing testing. And then also keep in mind too, that the building envelope performance verification is going to be required. So these are all things that you're going to have to keep in mind when you start thinking about what you're going to do for air leakage on the commercial side with the shipping containers. And remember too that, there's an awful lot of there's still going to be some joints and seams that are going to be involved. So there is going to have to be some other thoughts and information that's going to need to be provided on how you're going to deal with those joints and seams and make sure the material that's going to be utilized as that sealant is compatible for those particular materials, and including any type of penetrations that are going to happen with that. And then other than this particular, the thermal envelope components, the rest of this is going to comply with the remainder of the IECC, meaning your mechanical is going to comply with the mechanical, right? You're going to have to do your load calculations, whether it's a commercial load calculation or a manual J calculation. You're going to need to do your service water heating, any of your electrical, doing your watts per square foot or the amount of high efficacy bulbs that are installed, whatever the case may be. Those are still applying as if this was, the traditional stick framed construction. So all of those still comply. Where there's any sort of question really comes into play for your thermal envelope components. All right, car washes. I get questions quite often about car washes, and there's a lot of reasons why we get these questions, for car washes, because everybody thinks about the fact, and they're doing their due diligence, and they're wanting to do what's right when it comes to energy and dealing with this unique question. So why are these car washes in such great question? And the reason for that is because when you look at this, what is something that you see? You're seeing that one, there's a question about, is it going to be conditioned? And then where is that thermal envelope going to be at? Because the thought is, right, we're trying to make sure that everything is insulated where it should be insulated, everything is sealed where it should be sealed, and that we don't have really big holes in our thermal envelope. But what does a car wash have? We have a nice little giant hole on one end of the building where the, you know, vehicle enters that car wash. And then you have another giant opening on the other side of the building where the vehicle leaves the car wash. And so there's a lot of questions. What happens? What do I need to look at? What's all involved? And I think one of the first things you have to figure out for this is, are the spaces being conditioned? So, there we go. So this particular area on this plan, you can see there's offices, there's a bathroom, there's a control room. Those are areas that are probably, you know, one way or the other, you're thinking are going to be conditioned. And then you have other questions, right? What about this particular area that I highlighted in yellow? This area may be, you know, going to be conditioned. It's the mechanical equipment area. It's probably where, you know, water's being stored. And hey, we live in Colorado, and as we're all, you know, witnessing today with our lovely, lovely, beautiful, warm weather that we're experiencing, there's always a concern about, we don't want pipes freezing and busting, or we don't want the water to freeze on the ground and so forth. So, you know, is that space going to be conditioned? And then of course you have the ever so lovely large area, right? Is that going to be conditioned? Does it have to be conditioned? And, you know, that's a question for the, you know, the designer. The designer gets to determine whether or not this particular space is going to be conditioned. If it's going to be conditioned, then chances are it is going to be required to have a thermal envelope, but maybe it isn't. And so if that particular space where the basically where the cars go through there, it may qualify as a low energy building. And if it is a low energy building, or that particular portion of the building is a low energy building and happens to be separated from the remainder of the building that actually is conditioned, it would be exempt from that thermal envelope. So that top yellow area, if it happens to meet the requirement where it is 3.4, it's 3.4 or less BTUs an hour per square foot, or 1.0 watt per square foot of floor area for space conditioning, it is exempt from the thermal envelope. So how do we determine that? Well, to figure out whether it's going to be a low energy building, what you have to do is find out, you know, whether or not it's going to be conditioned. And here in Colorado, quite often when I'm getting these car washes, they are wanting to heat it. Now, I have various degrees of how much they're wanting to heat it. I have some car washes that are only wanting to heat it to like 40 degrees, just above, you know, freezing, where it's just enough where the water is not going to freeze over and cause issues with, you know, the car wash functioning, and making sure that none of the piping, you know, freezes and bursts, to where they want it fully conditioned as if, you know, people were living with inside that. And so those are the two type of situations that you're in. If they're going full force, I'm going to condition and heat this place because I don't want it to ever have the opportunity to freeze. At that point, they probably aren't going to make it as a low energy building. But I've also had some that were at, actually they were at 3.5 BTUs an hour per square foot. And that was a very, you know, unique situation, but that was their intent, was that they were going to be a low energy building. And the only reason why they were putting any heat in there was just to make sure that the pipes didn't burst. But in this particular particular plan that you see here, you probably notice that they have two heaters there, right? We've got number 2 and number 3 that are heating that top area that was in question. So if we add together those BTUs, we have 2.7.5. So the total is 415 MBH divided by the square footage, which is 2,163 square feet. You can do the math and see that they definitely are going to exceed that 3.4. So they are not going to qualify as a low energy building. So now, as you can see here on the plans, what they did do is they have a nice little thermal envelope here where it does completely do the exterior walls, and then a nice little area here too, where they were doing some more separation as far as where that thermal envelope is. Oops. There we go. So insulation of the thermal envelope is what we're going to be looking at. You know, the question is if they are putting in a thermal envelope, you're just utilizing the values and the requirements out of C 402.1. If they're putting in any sort of fenestration in there, it's going to need to comply with C 402.4, and that's for your U factor, solar heat gain coefficient. Your air barrier requirements are going to kick in. So you're going to go to C 402.5. And then of course, if you have fenestration, you need to make sure that it meets the air leakage. So you're going to go to table C 402.5.2 if you're in the 2018, or C 402.5.4 if you're in the 2021. Now, if you are in the 2021, there is another provision that comes into play that you're going to have to be aware of. And that is operable openings and the interlocking of it. So where there's an occupancy that's going to be utilizing an operable opening, you know, and the intent is, you know, those big giant garage doors that you're seeing quite often. And if it happens to be larger than 40 square feet in that particular area, then that opening has to be interlocked with the heating and cooling system so as to raise the cooling set point to 90 degrees and lower that heating set point to 55 degrees whenever that operable opening is open. And the change in heating and cooling set points will occur within 10 minutes of that opening happening. Now, there are some exceptions to this particular rule, but when we start talking about car washes, they really don't fall into any of these particular exceptions. And so the operable controls that are required just state that the heating and cooling systems must have controls that will interlock with these mechanical systems to change the set point to, like I said, the cooling at 90 degrees Fahrenheit and then the heating to 55. And they also have to shut off the system entirely if that outdoor temperature is below the 90 degrees Fahrenheit, or if it happens to be above 55 degrees. So these come into play here as a requirement to keep in mind when we are dealing with car washes. So that will come in the 2021. Now, let's talk about greenhouses and grow facilities. And keep in mind, which I'm sure we are fully aware of the fact that these are two very separate concepts. And so there is a definition when it comes to a greenhouse, and it's a structure or a thermally isolated area of a building that maintains a specialized sunlit environment exclusively used for and essential to the cultivation, protection, or maintenance of plants. So with that being said, if it is a greenhouse, greenhouses, and it meets that definition in the 2018, is exempt from all the building thermal envelope requirements, and greenhouses are grouped in that area of 402.1 that talks about for those low energy building sections. So if it happens to be a greenhouse and it is completely exempt from all the building thermal envelope requirements, you're going to skip section C 402 and you're just going to move to the mechanical system, the service water heating system, the electrical system, and all the other ones that are going to fall into play for this. Now, if you are in the 2021, greenhouses or areas that mechanically heat or cool those areas are exempt from the building thermal envelope requirements if they happen to meet the following requirements. If their exterior opaque envelope assemblies comply with sections C402.4 and C402.4.5, except for low energy greenhouses that comply with the C402.1.1, we just kind of showed that calculations, the 3.4 BTUs. Or if their interior if their interior partition and building thermal envelope assemblies that separate the greenhouse from that conditioned space meet those particular sections, and the fenestration assemblies that comply with the thermal envelope requirements in table C402.1.1.1 and the U factor for a roof for that assembly shall be included in this. So basically what they're saying is if you are choosing to heat or cool that greenhouse, now there are going to be a few items that you're going to have to comply with, because greenhouses, the intent of when this came in and when it was there was the fact that basically the sun was going to be doing all the work for it there. So there was no need for there to be any heating or cooling going on with that for the most part. And then, more and more was happening under greenhouses. So in the 2021, they kind of said, okay, there's no reason why if there's an opaque portion of that thermal envelope that they aren't, complying with what those particular requirements are. Just making sure that, things are kind of following with that. So in the 2021, these are the new requirements for greenhouses. Now, mechanical always applies, right? So mechanical, does it apply? Well, if you're utilizing any sort of mechanical and ventilation equipment used in these particular grow areas, and that it's probably more along the lines that this kind of comes into play more with the grow facilities or, and grow facilities, by the way, does not always mean marijuana. Grow facilities can be tomatoes, it can be basil, you can be growing anything that's green and planty, right? So it doesn't matter what that green plant is, if you are utilizing any sort of, mechanical heating for that or ventilation, you're going to be utilizing C403 and complying with that. So that means your heating and cooling load calculations are going to have to be supplied. Your equipment sizing, equipment efficiency, economizers, fan efficiencies, that's something to keep in mind with the ventilation and then any other section that's going to be involved with this particular project. Electrical power and lighting systems. Does it apply? Is any type of electrical lighting used in cultivating these particular products? And if there is, C405.2, the lighting controls, those are things that you're going to keep in mind, because the intent for this section, really is to make sure that the lighting is not needed for human use, that there are controls that can turn them off. And then, so for specific application controls, which is your C405.2.4 if you're 18 and C405.2.5 if you're 2021, the lighting for the non-visual applications such as plant growth shall be controlled by a time switch that is able to comply with section C405.2.2.1 that is independent of the controls for other lighting within the room or space. So that was a whole lot of stuff, but those are some of the controls that are required for that. Now, we all know that you're going to need to do that interior lighting power density calculation. And so with that, that's where you start adding up lights, what the watt is, where it is, what type of occupancy is it, or the function of that space. And that's going to determine how many watts you get. Now there is an exemption from that, and that is the task lighting for plant growth or for maintenance. And that is because, obviously the intent of that lighting being there is to grow the plants. The limiting the amount of wattage for it is going to be very difficult for that, right? That's not what we're trying to do. And so there is a new section that came in for the 2021 to kind of alleviate all of the questions or concerns about energy efficiency in these particular grow facilities, because I mean, you've seen the images on the screen and they demonstrate there's an awful lot of lighting that is being included with that. And so in the 2021, they wanted to address that. And so there's a new section, it's C405.4, and it talks about lighting requirements for plant growth and for maintenance. And what it says is not less than 95% of those permanently installed luminaires used for plant growth and maintenance shall have a photon efficiency of not less than the 1.6, I cannot say it, per joules, as defined in accordance with ANSI and ASA BES 640. And I apologize, I cannot say I know it's, yeah, I will butcher it, but it's blank joules, sorry. And the reason for that is because everything is kind of put into that lumens or watts term. And really, when everything is said and done, lumens are for humans. That's what humans, the light spectrum that they deal with and what we use. And it doesn't really correlate for how, the light spectrum that plants utilize. And so, trying to regulate lumens doesn't make sense when you're talking about for, plant growth. So there is this new efficiency when it comes to lighting for plants. And now it just must show that it has the photon efficiency that's not less than the 1.6, which from my understanding is readily available to find and have that information provided for you. And that is all that I have for you all. So I am very happy to answer any questions that you might have. These are very unique, and I tried to give you information as far as what are some of the most commonly asked questions that we get about these particular items. So with that being said, Erica, I'm happy to answer any questions anybody has.
Great, thank you, Hope. Yeah, we got a couple of questions for you. We'll start with the one in the Q&A, which is, with shipping containers, how do you address moisture in a kitchen or bathroom, commercial or residential?
And are you referring to, I guess I'm asking for, when you ask about moisture, are you asking about like the exhaust fans that are typically utilized to move moisture from these particular locations? Is that where the question that we're asking?
I would assume so, but I believe, Chris, do you want to, I'm going to go ahead and allow you to talk if you wouldn't mind clarifying for Hope.
Hi, Chris.
You'll just have to go ahead and unmute yourself and then.
Did I get it?
Yes,
got
I
it.
can hear you.
Yeah. So whenever I see the shipping containers and people are putting them in wherever, and I'm going, okay, well, I'm putting in a frame wall in front of that metal container. And so all of my insulation, just like you talked about, is right there. So my moisture hits that shipping container and gets everything all nice and wet there, and then goes to the floor, which again is some sort of plywood or OSB or whatever it might be. So how do we, I'm not sure I've got any place to tell them, you've got to get rid of this moisture somehow. And I guess that was my question, is how do you, what do you do there? How do you try to get rid of that moisture?
That's an excellent question, Chris. And it is something that I hate to say it, but it's kind of on this trial and figure it out situation, because we don't really have anything specifically called out that we can address that, other than what my suggestion would be is, you know, there are some things that are going to be required, right? You are going to still need that exhaust fan, you know, or those, you know, exhaust mechanisms that are going to be there, which will assist a little bit with that. But there's also the designer, when they are designing this, they need to have, you know, a really good understanding of the fact that, you know what, there is that possibility, and we don't want that moisture going on there, because you do have that dew point, right? You have that condensation that could very easily happen there. So there has to be some sort of acknowledgement for that, and that maybe that's a question, if you get those in, that is then presented to the architect, because the plans that I've gotten, I had a really good engineer that had done them, and he was very specific on how this stuff had to be designed and had to be installed to make sure that there wasn't that trapping the moisture, or you know, creating that new dew point that it didn't necessarily need, that we didn't want to have in the middle of that wall. And he was very good about specifying exactly how that wall assembly needed to be designed for that particular, because the one I'm thinking of right off the top of my head was a shipping container. They had 9 different shipping containers, and then they also had the typical traditional stick frame construction that was included with all of that. So the engineer took care of all of the shipping containers, and he was a firm that was very knowledgeable and had actually a lot of experience when it came to shipping containers and how to deal with them. So I'm sorry, Chris, I don't have a very specific, like, point you to a section within any of the codes that really kind of addresses that for you. In the 2021, there is some information on shipping containers. I think it's in chapter 31, but I don't think it addresses the question specifically that you asked.
Okay, thanks a lot.
Sure.
Okay, got a couple more questions in the chat. I think there's just a clarification here, but do you use input BTU, output BTUs to calculate the low energy building compliance?
Output BTUs.
Thank you. And then there was some discussion on log construction, it looks like. Give me a sec here. It looks like, you know, there's comments on why not just admit that log construction isn't appropriate for heated buildings. You know, there's some responses on people, you know, want to live in a heated log building, but do we exempt them from the energy rules or prohibit heating and cooling of log buildings? And then Patrick follows it up with, is there any sympathy for simply setting a maximum energy consumption for any building? Wouldn't that be 1,000 times less complicated?
Especially when you start looking at that calculation, right? That calculation I showed, if you chose that method, that seems like an awful lot. And Log Homes does have a lot of discussions around that, because like I said, if you went with the option, that first option in the prescriptive, where you're using that table and you're using the gravity specific, and that deals with the moisture and then the size of log, you know, it addresses, you know, meeting the thermal envelope for the log wall. But again, what are you going to do for the ceiling? And, you know, so there are some things, of course, that could be improved upon. And I haven't had the opportunity yet. I know there was a lot of discussion and a lot of interest in that particular section, the 306 out of ICC 400, to be worked on to try to be a little bit more, you know, energy efficient, and still allowing for those aesthetics to be in that. And so I haven't looked at the 2021. Maybe they address some of these concerns, because I can tell you I've reached out to the chair on that, and I've had some discussions with with people concerning that. So, well, we'll see if, anything, really came about from that. But yeah, if not, I say we all get together, and in 4 years, when they start working on the standard again, let's all take a look at that energy section and see what we can do to improve upon it, and yet still allow for, that freedom of choice of utilizing it. But there's got to be, something we can do to improve upon that section. So I challenge you all, come meet with me in 4 years.
Sounds good, Hope. We do have a question from Gary about getting credit for the class. I'll be sending out
Okay.
certificates for this class within the next week or so. So Gary, I have your email and everything, and everyone gets a certificate where they can then self-report any credits. All right, I think if there's anyone that wants to raise their hand, feel free to do so. Otherwise, I think that's all the questions. And I'm going to go ahead and stop the recording now.